So, good morning, everyone, for the grand rounds of today here at the Division of Occupational Medicine at Mount Sinai. We have the pleasure to have Dr. Ryan Hoy. He is a pulmonologist and a senior research fellow at the Monash Center for Occupational and Environmental Health in the School of Public Health and Preventive Medicine, Faculty of Medicine, Nursing and Health Sciences. Is all encompassing at Monash University in Melbourne, Australia. So he's going to talk to us about artificial stone silicosis and these beautiful quartz countertops that you see in your Home Depots. Ryan, thank you very much for accepting our invitation and for staying this late in Melbourne, Australia.
Thanks, Rafael. Yes, it's a little after midnight. So if I start rambling incoherently, you know why. But no, it's all good. Thanks very much for the invitation. So just to orientate you, yes, I'm from Melbourne and Victoria, Australia. So we've got about 5 million people in Melbourne. So this is my hospital, so the Alfred Hospital, and our research centre is here at one of the offshoots of Monash University. And anybody that's a Grand Prix fan, this is the Albert Park Lake Circuit, where we host the Formula One Grand Prix every year, just around the corner from the hospital. So I'm going to go through a case presentation. I'm going to talk to you about the hazard, which is artificial stone. I'm going to talk about what we've learned from screening a lot of workers in the stone benchtop industry in Australia. So in America, I know you talk about countertops. In Australia, we tend to talk about benchtops. So I'll probably go back and forth between the two. And I'm going to be talking a bit about what we're doing about artificial stone silicosis in Australia at this point in time. So just to start with a representative case. So this is a 30-year-old man that's been referred for occupational health screening due to occupational silica dust exposure. So he migrated to Australia from India when he was 15 years of age. He's got no past history of lung disease, no known history of tuberculosis exposure, and no family history of relevance. He is a current smoker, so he smokes 10 cigarettes a day, and he has a history of 12 pack years of smoking. Never undergone occupational health screening previously. So talking about his symptoms, he's got some mild shortness of breath. He notes this when he's playing cricket on the weekends, when he's running through a ball. His modified medical research score, however, is 0. So I only get short of breath with strenuous exercise. He's had no skin symptoms, no joint symptoms, and no eye symptoms. And respiratory examination is really unremarkable. So in terms of his occupational history, so he works at a business that produces stone countertops, and he's been working for this business for 8 years. There are 10 workers in the factory, and they also employ 4 installers that go out and install the benchtops on site. And the company primarily supplies builders that produce new homes, but they're also involved in renovations of older homes around the eastern suburbs of Melbourne. And 90% of the work is with artificial or engineered stone. So the company buys these slabs of stone. So we import these into Australia, and I'll talk more about this coming up. But these slabs need to be modified to go into a house. So they're modified based on the client's recommendations, their specifications, where the taps go, where the sink goes, where the cooktop goes. So his job is a stone benchtop fabricator, or sometimes this role is referred to as being a shaper. So in his job, in his business, he uses a hand tool to do this. So he'll use a handheld circular saw or grinder, as you can see being done here, following a little template to cut out the hole where the sink goes. So you can see similar work being done here, also with a type of grinder. This is where the edge of the stone is cut, so the two slabs can actually be put together with a mitered edge. So it's a nice sort of flush edge. He does this 5 days a week. He works really quite long hours, 8 to 10 hours a day. There's been no water dust suppression used on these hand tools when he's operating the circular saw or grinder. They have two doors open in the factory, so front and back door, and they use a fan to try to blow dust out of the factory. And there are 10 other workers that are doing this work in the factory, so there's a lot of visible dust in the factory. And this is some representative photos of what some workers look like doing this type of work. So really covered in dust, as you can see here. He, like a lot of other workers here, have provided a half-face, non-powered cartridge respirator. But you can see the amount of dust that's just on clothes and on the face of these two workers. So in terms of screening investigations, so we do spirometry and gas transfers. So spirometry shows a moderate obstructive defect with a borderline bronchodilator response. Gas transfers within the normal range. So we do a panel of blood tests as well. So serum angiotensin converting enzyme level is quite elevated, so about 109. His autoimmune screen is negative, ESR is slightly elevated, and screening for latent tuberculosis is negative. So he has a non-contrast CT chest as part of his screening. And this really shows quite a marked abnormality. So he's got mediastinal and high lymphadenopathy, which is non-calcified. He's got extensive background small pulmonary nodules throughout both lung fields, as you can see really scattered here. There are ground glass nodules and there are more solid nodules. But obviously the major finding here are these large conglomerated masses in the upper lobes bilaterally, and this is very consistent with progressive massive fibrosis. So he has the diagnosis of accelerated complicated silicosis. He's been working in the industry for less than 10 years, which is in keeping with the accelerated form of silicosis and complicated based on the radiological findings. And certainly, in my opinion, he very likely actually has occupational asthma as well, which I won't go into detail here. He's certainly not fit to return to work in the stone benchtop industry due to the risk of further silica dust exposure. We support him in terms of helping him submit a work cover insurance claim, so workers' compensation insurance. And we start him on medication for his asthma. We refer him to our smoking cessation clinic to help support him to quit smoking. And we want to get him back to our clinic pretty quickly. So back in 3 months, when we have an initial consultation like this and make a diagnosis, there's a lot going on in that consultation. So we want to get a worker back quite soon. We certainly want to refer him pretty early to a psychologist and probably an exercise physiologist as well, because we understand there's a really significant mental health impact of this diagnosis and also physical effects as well. We think that getting workers back to suitable alternate work is really important. So we're going to be thinking about what alternate work options may be acceptable for him. But, he's at significant risk of disease progression. So we may be thinking about an antifibrotic agent like nintedanib. But unfortunately, it's quite likely he's going to require a referral to our lung transplantation service, which is at our hospital as well. So how likely is it that he's going to decline? This is a really important paper by Antonio Leon Jimenez and his group from Cadiz in Spain that they published in 2020. And so they've been following up a cohort of about 100 patients with artificial stone silicosis. And this publication was looking at follow-up over a mean period of 4 years. And they found that there was a particular group, so about 25%, that really had a very rapid decline in lung function. So with an annual loss of greater than 150 mils per year in vital capacity. And really interestingly and really concerningly, you can see here as well, looking at follow-up chest x-rays over time, in that initial group, when they were diagnosed, 5 had features of PMF, and then by the end, there were 31 that were identified with PMF. So I caught up with Antonio not too long ago, and he continues to follow these patients and remains very concerned about their ongoing decline, even though it's been many, many years since they actually were exposed to silica dust. So the hazard, so artificial stone. So I think we just need to talk a little bit about what this material is and the risk related to it. So artificial stone comes by a lot of different names. So we sometimes talk about it as engineered stone, reconstituted stone. A lot of our workers just call it recon. Quartz conglomerate, though, I know is a more sort of common terminology for it in North America. It was a process that was actually developed in Europe in the late 1980s to actually produce this material. So it's this thing called the Brenton method. And the slabs of stone aren't actually produced in Australia. We don't actually have any manufacturing of the actual slabs in Australia. So we import it, unlike in the US, where I know you do have some manufacturing facilities. There are lots of manufacturers of this material now. So Caesar stone is probably the one that most people are familiar with. Essa stone, Silestone, Smart Stone, some of the other brands that we have here in Australia. But there are lots and lots and lots of other manufacturers, and we're seeing a lot now being manufactured in a lot of Asian countries and then being imported into Australia. It's become enormously popular in the domestic kitchen market. It's far cheaper than a lot of the natural stones like marble and granite. But one of the other reasons why it's really popular is that you can get in any color that you want. You can get in green or red or brown or really whatever you want. So, that way kitchen designers can really use it based and really design their kitchens around it. It's also got a lot of properties which make it really useful for a domestic kitchen point of view. So it's non-porous, it's scratch and stain resistant. So if you have white marble and you spill red wine on it, so marble can be quite porous and it actually can absorb that wine, whereas this won't do that. So again, it's one of the reasons why it's become very popular. It's got 4 times the flexural strength and double the impact resistance of granite as well. This is something I said I would never do, is actually put a video in a presentation, but I've broken that rule. I think this is just a quite interesting video from YouTube that is an artificial stone manufacturing company from China. I just want to show you just some of the aspects of the manufacturing process. So I'm just going to skip forward a little bit here. So what you can see here is the workers spreading out the silica sand, which is mixed with a resin to make it stick together. You can actually see in the processing here, the chute, which actually delivers the silica sand. And if I just pause it there for a moment, you can actually see in the background just the bags and bags of silica that's outside ready to be used in this process. And then just to start it up again. And then so it comes along from that initial area and goes through this machine, which is known by different names, but the initial one was called the Brenton machine. And essentially it's a vibro compaction machine. So it compacts that material down to this really firm slab that you can see here, which then still needs to be polished and heat cured. But you can sort of see the process of developing this slab of stone. So it's certainly anything but a natural product. What's the issue with this? Well, primarily it's the silica content. So this is a material that contains greater than 85% crystalline silica. And so workers, certainly in Australia, we're very used to using marble and granite, which contain, marble's only about 2% silica, granite around about 30% silica. And then all of a sudden, from the early 2000s, there was introduction of this material, which contains greater than 85% crystalline silica. And so there was very little education provided to workers and businesses about the difference in handling this material, which has led to a lot of the problems we've seen. And this is just some information from the Caesar Stone website, which is their material safety data sheet, which indicates some of the components of their stone slabs. And you can see here, so they note that quartz or silica sand. It's a bit unusual that this range is so big here. So for an MSDS, to have a range of 24 to 92%, quartz, really doesn't help in terms of looking at the hazard level of that material. But, it's got a lot of other components to it as well. So in particular, polyester resin being the main binding agent that's used in it, but a lot of decorative features as well. So glass and mirrors may be in it, and pigments as well. So just to sort of go through again some of these processes. So this is the
I
slab.
have a question. Why
Yeah, sure.
cristobalite is
Yeah,
yeah, why did it separate it?
I know. Thanks, Raphael. I know it's a bit of an odd one, that one. I only found this today. Actually, I got the latest MSDS. I'm not sure. So I think that there is evidence that when these workers are cutting it, because of the intensity of it, you can actually produce crystal ice as a result of that. But actually, in the material itself, I don't know.
Okay.
It's a bit odd. There's a lot of odd things in this area. So as I say, these slabs are then need to be modified to go into your kitchen, so based on your designer. And so what's been happening really commonly is that this has been done without any water dust suppression or really any hazard control measures at all. You can see this worker here doesn't even have any sort of mask, even though we know that respiratory protection is the lowest level of control measures. This worker isn't even provided that. Another video for you. So this is a worker cutting a artificial stone slab, but I think it's just helpful to look at it just to see the intensity of this work with a grinder. So you can see there the dust that's being generated. You can see even here, the sparks that are being generated just by the heat of this. So this is a really high intensity activity when workers take a grinder or a circular saw to this material. So what happens when workers do that? There's very little research that's been done to actually provide us information about the silica levels that are produced when workers do this sort of thing. This is one study that was published a few years ago now. And what they did was that they used a circular saw and cut through artificial stone, and doing it dry, so with no water dust suppression, no other engineering controls at all. The amount of silica that's produced over one sampled 30-minute work period was 44 milligrams per cubic meter. I know that short-term exposure limits are pretty a little bit limited in this area, but generally, we wouldn't want that over about 0.3. And really, we shouldn't have any single level above 0.5. So, this is obviously, hugely in exceedance of that. And that's just over a 30-minute work period. So, you extrapolate that over to a full day of work, day after day after day, you really get a sense as to the level of silica that these workers have been exposed to. We're certainly here, we're really trying to push the really strict enforcement of no dry processing. But what I think people really need to understand as well is that using water to suppress dust generation is not the answer, though. It will substantially reduce the amount of silica that's produced, but it won't eliminate it completely. As you can see here, still using water, so wet blade and water curtain reduces it, but still have significantly higher levels of silica dust generation. So this practice of dry processing, how common is it? It's extremely common. So certainly in Victoria, based on our work, this is data from 402 screened stone benchtop workers. So 85% had been exposed to dry processing. The 44 noted that spent over 50% of their work time in an environment where dry processing was occurring. And looking at the literature, this has been reported internationally. It's certainly not just in Australia that this is happening. Certainly in the US, in China, Israel, Belgium, Italy, Spain, there's many reports of this dry processing activity. This is a recent publication from the US, which investigated a workplace that produced bench tops and fabricated bench tops from that material. And they identified 16 with work-related asthma, which is a really interesting and important issue here as well. I know we're focusing on silicosis today, but 12 with silicosis. But I think it's just important to highlight here what they found in terms of the occupational hygiene assessment part of the study. And so they found in the sanding area, and these workers were sanding roughly 100 countertops per day. So the downdraft tables were either malfunctioning or they were turned off. So there was no local exhaust ventilation. And so 2 of the sanders had to be sampled twice because the sampling filters became so overloaded with dust during their first attempt of sampling. And so, this is something that not for this audience, but for, my other respiratory colleagues, I always remind them about how much silica actually needs to be inhaled to be above the exposure standard. And it's such a small amount. This is a 5-cent piece, which, I think if my memory of US coins is right, it's probably about the size of a dime. This is the amount of dust you need to inhale to be above the exposure standard. And so, whereas this is an image from a Chinese stone fabrication business, and you can just see the mounds of dust that's accumulated around the workshop. So, these workers are using really high intensity power tools. They've got little or no dust control measures, and they're producing these respirable sized particles. And a lot of the research now shows that a significant proportion of particles are actually in the nano-sized range. They're exposed to very high intense periods of silica. They're producing these freshly fractured particles under high levels of pressure. And those freshly fractured particles are much more reactive than aged quartz particles. And then there's other components of this artificial stone dust, so metal ions. There's also volatile organic compounds like styrene and toluene as well, which we know can have a wide range of other effects. There are some ways that potentially you could deal with this material, I put safely in inverted commas. This is a water jet machine, and this is a water jet machine as well. And these are computer operated machines, so CNC machines, which use water, high-powered water, to actually cut the stone. The issue is with these machines, they are enormously expensive. You're looking at, well over $100,000 for a lot of these machines. So some companies have invested in them, but the vast majority of companies still use the hand measures. So what's screening taught us so far in Australia? We've been screening a lot of workers, certainly here in Victoria and in Queensland. So silicosis in Australia, essentially, we thought was a non-issue. And to be honest, I think that a lot of occupational respiratory diseases were not really that well considered in Australia up until recently. There was this parliamentary investigation back in 2005, and an expert commented to that committee that the silica issue in medical terms in Australia is over. It's a great success story, and Australian industry is free of silicosis by and large. So really, we were very much asleep at the wheel when it came to this issue developing. So artificial stone was introduced into Australia in about 2000, so the early 2000s. The first case of artificial stone silicosis in an Australian worker was reported in 2015. Then in 2018, myself and colleagues identified 7 cases just through discussion in our network of artificial stone silicosis. And we published that report. And it was around this time, about 2018, there was an increase in media attention about this issue, which I'll come to in a moment. And then in 2019, there was commencement of some active screening programs. I think certainly with increased evidence of a problem and increased media attention, there was really pressure on government to do more in this area. And one of the actions was screening programs. And, having had the first case identified in 2015, in 2022, we now have close to 600 workers that have been diagnosed with silicosis from this industry. And this is really a significant underestimation still of the number of cases that are out there, number of workers that are affected by this. The biggest screening program to date that's published their outcomes is the Queensland program. and they screened 1,052 workers in the industry between 2019 and 2021, and identified 23% with silicosis. I'll talk about our data from Victoria in a moment, but really the prevalence that we've seen in Victoria has actually been very, very similar to what's been seen in Queensland. And this really represents the largest epidemic of an occupational respiratory disease in Australia since the banning of asbestos-containing materials. So it really was with increased media attention that we started to see some action on this issue. Really from 2015, we were knocking on doors of politicians, of the regulatory agency to actually do more. But it really was when workers started talking out about how terrible the conditions are in this industry that really the media really got engaged with this issue, and really change happened. And one of these workers was this gentleman, Anthony White, and Anthony was a stonemason from the Gold Coast in Queensland, and he really was, as I say, one of the first to talk about this. And really tragically, Anthony died as a result of silicosis a bit over a year ago now. So he was waiting for a lung transplant and unfortunately deteriorated too quickly before he could get his transplant. So there has been a lot of activity since that time. And one of these has been a free screening program for stonemasons in Victoria, so in the state that I'm in. And this is a program that was launched in June 2019 and finished in October 2021. And so the protocol for this program was developed in conjunction with our group at Monash University. And it was open to any current or former stonemason in Victoria. We talk about stonemasons, but really the focus was on the stone benchtop industry. And really the aim of this was to provide really comprehensive health assessment to identify all forms of silica-associated disease amongst these workers. It's a baseline for future health assessments, but also to provide each worker individual patient management, whether they've actually got silicosis or not. And obviously it provides a really important resource for research to better understand this industry and silica-associated diseases. I won't go through this in detail. We have published this protocol in OEM last year, but essentially it was a staged program. So we would do a primary evaluation where the worker would have would complete a standardized questionnaire. They'd be assessed by an occupational and environmental physician. They'd have lung function with spirometry and gas transfer. They'd have a chest X-ray, which was reported by the certified B reader with ILO classification. And then if certain criteria were met, then they would go on and have secondary evaluation, which included the CT scan, bloods, and then they would see a respiratory physician. So just to touch on those criteria, so that was if you had an ILO perfusion subcategory of greater than 0/1, if you had lung function which was abnormal, so below the lower limit of normal, or you had symptoms or physical signs that the occupational physician thought were significant that required further investigation, or based on the exposure history, you had a high or very high silica exposure level. And we determined that based on your duration of work in the industry and also the highest level exposure you had to dry processing, which I'll talk about in a moment. And so 77% of those that participated required that secondary screening. So in terms of the outcomes from that, so we're about to submit for publication the final outcomes. So this is an interim analysis that I'm presenting to you today. So this was between July 2019 and August 2022. So at that time, we had 402 screened workers that consented to participate in our research that were given a final diagnosis, and 107 of those, so 26%, were diagnosed with silicosis. So 89 was simple and 18 with complicated silicosis. 100% of those with silicosis were male. Importantly, about half were born in a country other than Australia, so especially from Asian countries. We've got a lot of workers, especially in Melbourne, that come from Vietnam that have ended up working in this industry. So I just want to talk a bit about some of the investigations, so screening investigations. What we found was that because we have a lot of patients that had chest X-ray and CT, 30% of those with a positive result on CT actually had a normal chest X-ray. So perfusion score is 0/0 or 0/1. So meaning that if we use just chest X-ray, even if it is reported by a qualified B reader, 30% of cases would have been missed if they didn't have a CT of their chest performed. And this just gives you an idea of the radiological spectrum of silicosis that we've seen. So it could be just a few small nodules in the upper lobes that you can see here, or another case of simple silicosis with really extensive small nodules in both lung fields, or this patient here with complicated silicosis, so with these conglomerated masses and a lot of small nodules in the background. And so all these patients were picked up through screening. And just to mention respiratory function testing, we know that spirometry is a significant component of silica health screening. What we found, however, in this workforce was that those with silicosis, their mean percentage predicted values for the spirometric parameters, so FEV1 and FVC, were above 90%. So if you were using even a percentage level of 80% or a lower limit of normal, you're going to be missing nearly all of these patients with silicosis. Whether this is because it's a young male workforce, we don't know what their baseline lung function has been, how much change there has been over time, but it just flags that certainly chest X-ray and spirometry are really poor tools to identify silicosis in this group. We have found that gas transfer, so DLCO, is lower, especially with complicated silicosis, which would make sense, but still not low enough to use it as a screening tool. Raphael, you got a question there?
I have two, actually.
Sure.
One of them is, are these Asian workers mostly first generation and have language barriers?
Yeah, absolutely. And
Yeah.
it's been one of the tragic things that a lot of these workers from Vietnam came to Australia as refugees for a better life in Australia and ended up working in this industry. But yeah, we almost have a Vietnamese interpreter with us every day in clinic now because of this issue.
Okay. Another one was in the organization of this screening. I know that the government of the state it has been involved. The WorkSafe is a state organization, but has there been participation? To what extent, actually, start backwards. To what extent is this work population unionized? Do they belong to unions? Because first generation immigrants, for the most part, and we have observed that here in some cases, are not union members. So can you tell us a little bit of the background and how and if they participated in the organization of these screening programs?
Yeah, no, it's a really good question because it's so important in terms of worker representation. And no, like the vast majority of these are really small or micro businesses where there may be 2 workers at the business or maybe 10. We get the occasional one which has more like 50 to 100 workers, but that's really rare for us. Really, they are very small businesses. But the unions have been very concerned about this issue and have been very vocal and have been really helpful in terms of continuing pressure on this industry and also really encouraging the government to do more, especially the regulatory agency. So, the unions have been a really important partner for us to keep this issue on the agenda.
So the unions, but they are not the unions of these workers. They are other
No, they're not.
unions.
No,
Exactly.
exactly.
So they are
Correct.
solidarity unions.
Exactly. So it's mostly been the building and construction union. So they are obviously, they run sort of very big construction process where this material is actually installed. So they see it coming in and, they've been more and more worried about when some installation is done on site and there is some modification of the stone on site, and what that would result in terms of their union members that are on site. So yeah, but there definitely is solidarity there as well.
So for context, what percentage of the work population in the state is Victoria, right?
Correct.
Yeah, is unionized.
Or
Would you say? Do you know? Is it
I would say probably half. I'd probably say
okay,
half. Yeah.
that's okay.
Yeah.
All right. So there is a question about control measure, but I know from having introduced you before that you're going to address that. Like, how can it be prevented? But you'll cover that, I'm sure.
Yeah. So I'll do just a couple more things we found out through the screening program. So we did take bloods as part of this. And so we found that 28% of those that were screened had detectable anti-nuclear antibodies. And some of these were really low levels. So, an ANA titer of 1N80, so pretty low. But, looking at the background population rate in healthy males, that would actually be about 9%. And we're certainly seeing cases of scleroderma, rheumatoid arthritis, and vasculitis in this group too. Serum angiotensin converting enzyme levels, we've seen, as I mentioned in the case at the beginning, that patient had a really high level of ACE. And, we've seen that time and time again. And this was a paper we published last year, which shows that certainly there was a trend for an increase in serum ACE levels based on the presence of silicosis and severity. It's been one of these issues, and I think that a lot of the early cases before this was better recognized were misdiagnosed as sarcoidosis. So I think I've seen some patients that probably had an identifiable diagnosis back sort of 2013, 2014, but were told it was sarcoid, but clearly they actually have silicosis. And, we see serum angiotensin converting enzyme being released by activated macrophages, which is why it's elevated in silicosis in addition to sarcoid. But just also in that group, so in our cohort in Victoria, so the mean age was 42, so, really young group of workers, and about 11 years in the industry. And in terms of the longest held job, the factory machinists and the installers really had the highest risk of silicosis. And so we've looked also at the level of risk, the number of cases diagnosed based on their exposure to dry processing and duration in the industry. And I think it's just important to note here, so those that had high or very high exposures, 30% had a diagnosis of silicosis. So there are some here, quite, 70% or so, that did not have silicosis despite a very high level of exposure. We're still concerned about what happens to this group. I think, certainly in my opinion, there is a significant risk they'll develop disease in the future. And also in the low-level group, so those that actually had never been exposed to dry processing, we still had cases of silicosis being identified. So this is a huge industry internationally. This is a $15 billion industry worldwide, and it just keeps increasing and increasing. Certainly in the US, this is data from 2016, where 14% of the countertop market was from Quartz. I would expect that's probably 30% now, the way that it was increasing. And so this is not just an Australian problem. Like, this has been occurring all around the world. So this is results from Spain, with a rapid increase in the number of cases of silicosis due to artificial stone. We're seeing a lot of reports coming out of China. This is a report from Italy and from Belgium here. And, when you look at these CTs, and it's always fascinating to me when the authors publish the CT findings too, and we see exactly the same radiological findings as you see here. Just going back to the US, so this, I'm sure many of you have seen this, this paper from 2019, which detailed 18 cases of silicosis from working with engineered stone. And similar to us, so, young workforce, so 11 out of 18 were less than 50, severe progressive disease, dry processing being identified, and high levels of silica being identified in at least one workplace that was assessed. And so, again, this is probably, to me, the most concerning part of this publication, knowing now what the prevalence of disease we're seeing in Australia is. And they reported an 800% increase in the use of quartz surfaces between 2010 and 2018. So close to 9,000 establishments and almost 100,000 workers in this industry in the US. And so even a more conservative disease prevalence of 20% would be 19,000 cases of silicosis. That's pretty scary, and, I think when we started to see the first few cases here in Australia, we thought, it could have the potential of being something terrible. And what we've seen actually has been what we really hoped would not happen, would be the extent of disease we've seen. Many here in this report were Hispanic immigrants. So again, similar to, as we talked about before, what we've seen in Victoria with a lot of migrant workers and the issues that those workers have. And just to briefly mention, because I do want to have some time for discussion of what else we're doing here in Victoria. So there's been a lot of work by the regulatory agencies. So there's been, since 2019, really enhanced inspections. So there's a dedicated silica field team now that goes out to these businesses. There's been a ban on uncontrolled dry cutting of stone. So they really strictly enforce this now. And having seen workers in this industry for quite a few years now, I've seen really drastic changes in work processes, which has been really good. But, there's still a long way to go while this material is still being used. So we've now licensed every business. So if you actually purchase an engineered stone product and you sell it, then you need to be licensed by the government to do that, which means providing the government your dust management plan, the results of your dust level monitoring, so your atmospheric monitoring, your health monitoring plan for all your workers. So they're really strictly looking at this industry now. And we've developed a dedicated occupational lung disease clinic at the Alfred Hospital, which I'm part of. And I think an important document for you to have a look at as well is the new engineered stone compliance code, which you can download from the WorkSafe Victoria website here. And it's a really detailed document which goes through what, at this point in time, we recommend in terms of control measures. But, we're all here and we all understand the hierarchy of controls, in our area of work. And we know that elimination is the very top of that hierarchy. And I think we need to be having an ongoing discussion about this. I was part of the National Dust Disease Task Force, which was operated by the federal government. And as part of our recommendations was that we really need to be moving towards a full importation ban on this material by July 2024, if there's not substantial improvements in the industry. That recommendation hasn't been completely accepted by all governments at this point in time, but there certainly, is, I think, a mood towards that again here in Australia. So whether it's going to happen or not, I'm not too sure if the horse is bolted, but I'm certainly thinking, from my point of view, that's really what we should be working towards. So just in conclusion, this is an entirely preventable and potentially fatal occupational lung disease. This is a new material. We've survived without it for a long time. It's only been with us for about the last 2 decades. And it's grown at an extremely fast rate and really unchecked, in my opinion, really in terms of its use and monitoring of businesses that actually do use it. And clearly there's been inadequate hazard control measures in this industry. And really, it's only been through proactive screening of workers in this industry we've identified the extent of the problem. And I really would encourage consideration of CT imaging to assist with that. And really, as I said before, our current estimate in Australia is a disease prevalence of 25% in this industry of silicosis, let alone thinking about the other health effects like the autoimmune disease, the long-term risk of lung cancer as well. And so really urgent measures are required to protect workers in this industry, certainly in Australia and internationally. So happy to take any questions or discussion.